A severe geomagnetic storm could cause colorful auroras over Northern California and Alabama. Colorful auroras could be visible in areas of the United States such as Alabama and Northern California, much farther south than they typically appear, on Thursday evening due to a powerful solar flare and coronal mass ejection released from the sun, according to the National Weather Service's Space Weather Prediction Center. The severe solar storm, initially classified as a level 4 on a scale from 1 to 5, also could disrupt communications, the power grid, and satellite operations, according to officials at the center. The storm reached Earth at 11:17 a.m. ET Thursday, with the potential to last through Friday. While G3, or strong storm conditions, were observed at 11:49 p.m. ET, scientists at the center confirmed the storm reached G4 conditions at 12:57 p.m. ET. The storm arrived at Earth, moving at 1.5 million miles per hour, about 2.4 million kilometers per hour, and reached the Deep Space Climate Observatory and the Advanced Composition Explorer satellites orbiting 1 million miles from Earth about 15 to 30 minutes beforehand. The satellites measure the speed and magnetic intensity of the storm, said Sean Dahl, service coordinator for the Space Weather Prediction Center, at a news briefing Wednesday. A series of the most intense type of solar flares, known as X-class flares, have released from the sun this week. The flares also coincided with coronal mass ejections on Tuesday. Coronal mass ejections, or CMEs, are large clouds of ionized gas called plasma and magnetic fields that erupt from the sun's outer atmosphere. When these outbursts are directed at Earth, they can cause geomagnetic storms, or major disturbances of Earth's magnetic field. Geomagnetic storms can impact infrastructure in near-Earth orbit and on Earth's surface, according to the Space Weather Prediction Center. As a result, the center has notified the Federal Emergency Management Agency, the North American Power Grid, and satellite operators to prepare for disruptions, especially given the amount of preparations and expected relief efforts for Hurricane Milton, Dahl said. Historically, G4 storms are common during a solar cycle, but G5, or extreme geomagnetic storms such as the one that occurred on May 10th, are incredibly rare, Dahl said. This new storm has a 25% chance of becoming a G5, he said. An uptick in solar activity. As the sun nears solar maximum, the peak in its 11-year cycle, expected this year, it becomes more active, and researchers have observed increasingly intense solar flares erupting from the fiery orb. Increased solar activity causes auroras that dance around Earth's poles, known as the Northern Lights, or Aurora Borealis, and Southern Lights, or Aurora Australis. When the energized particles from coronal mass ejections reach Earth's magnetic field, they interact with gases in the atmosphere to create those different colored lights in the sky. Currently, scientists at the Prediction Center believe visible auroras are likely to appear in central eastern states and the lower Midwest, but it remains to be seen whether the storm will cause a global phenomenon of auroras, as the G5 in May did, Dahl said. But if the storm escalates to a G5, auroras could be visible across southern states and elsewhere around the world. National Oceanic and Atmospheric Administration officials recommend using the center's Aurora dashboard to find out whether northern and southern lights are predicted to be visible in your area. The dashboard is constantly updated and can show where an aurora may appear within minutes of the information becoming available. The chance of seeing auroras has also dramatically increased, given that darkness falls earlier during this time of year. Sky gazers in the U.S. who spied auroras caused by a G3 storm over the weekend witnessed the northern lights within an hour or two after nightfall, Dahl said. And even if the colorful displays don't seem apparent to the naked eye, sensors in cameras and cell phone cameras can pick them up, center officials said. Potential for disruptions. NOAA scientists said they don't believe this week's storm will surpass the one in May. Before then, the last G5 storm to hit Earth was in 2003, resulting in power outages in Sweden and damaging power transformers in South Africa. During the May geomagnetic storm, tractor company John Deere reported that some customers reliant on GPS for precision farming experienced a disruption. But for the most part, power grid and satellite operators kept satellites in order and properly in orbit, and manage the buildup of intense geomagnetic currents on the grid systems. The solar storm in May was the most successfully mitigated space weather storm in history, Dahl said. Scientists are continuing to monitor the spikes in solar activity as they increase because they could indicate where the sun currently is in its cycle. The speed of Tuesday's coronal mass ejection surprised scientists at the center because it's the fastest measured in this solar cycle so far, Dahl said. But that doesn't mean the peak of solar activity is occurring right now. Previous solar cycles have shown that some of the biggest storms can happen after the peak, he said. We are in the midst of solar maximum right now. We just don't know if we reached the peak yet, Dahl said. That would be decided later and could be either sometime this year or even early next year. Bottom line is, we're still in for a ride with the solar cycle activity through this year, as well as the next year, and even into early 2026.